All right, welcome. What we're going to talk about is we're going to talk about lines and how to find lines. This is one of the key components on how to do basically almost anything in math. And learn in Algebra 1, this is the first equation you learn is what is known as linear functions. Linear functions. So, without further ado, what are the key components that you need for a line? Well, a lot of math teachers, or at least in a lot of books, when they first start talking about lines, one of the things you need to know is about slope. That is very true. However, when people start talking about equations of lines, students sometimes get really confused because they learn this form called slope-intercept form. At least this is from my experience. When students learn slope-intercept form, they memorize this equation, y equals mx plus b. One of the great fundamental equations and one of the elementary equations that a student learns in mathematics. However, a lot of times when students learn this equation, they get mixed up on what is a slope, what's the y-intercept, and how do you really create an equation of a line, because they get so confused with all these different variables. So when I teach lines and how to write the equations, I do not spend a lot of time on slope-intercept, which is also very, very important. But more importantly, I look at what is called point-slope form, because it really gets to the heart and point of what you need to find the equation of a line, which is known as a slope and a point. That is all you need to find the equation of a line. A slope and a point. A constant change and a starting or a value that you are increasing or decreasing this constant change. All right, so this is what point slope form is. This is a general form. This is not a transformational form. There's other ways of writing this down, but this is what I use because this is what's known as an explicit form. You have the y isolated. This is a function form where y is in terms of x, okay? Where m is what's known as a slope, all right? And the x sub 1, x, y sub 1, those are our two, or actually 1 point. All right, so this point can be any point on our linear equation. All right, so we're going to talk about how to find the equation of a line in this tutorial. We're going to go through and how to use this point slope form, how to find the slope, and then all the other cool stuff. There's also another form that is known as general form. If you want to write that down, you can. It's good that you be able to identify this, but a lot of times we don't put those in the form unless the book asks you to or whatnot. It has its place, but many times point slope form and slope-intercept form are the keys. All right, so let's try a problem. Find the equation of a line given the coordinates a, -3, 2, and -1, -2. All right, so how do you find the equation of a line? Well, we're given 2 points, and what you need is a point and a slope. That's what I always say, point and a slope. So how do you find our point? Well, we're given 2 points. So what you have to do is you have to just pick which one you want to use. So we are going to use, I'm going to use a highlighter here. All right, I'm going to use point, let's just use point 8 because that's the first one. So I'm going to use point 8 in our point slope form. All right, so if you were to graph this, all right, I'm going to take my pen again. Sorry about that. All right, and what we got is we're going to start with this point. And this point's going to be at -3, 2. So we're going to go 1, 2, 3, -3, and up 2. And we have a point about right there. And that's our first point. That's going to be point A. Now, we have another point, all right, which we need because our other point's going to help us find our slope. All right, because it's going to help us create a triangle and we can figure out our rise or run because that's how you find slope. So we're going to have our point, which is -1, -2. So here's our other point. All right. And we have this. We can connect their dots. I'm going to create, see if we can do this. All right. And it's not going to be a total line. It's going to be a line segment, but connect those 2 lines, and that's what we have. All right. So we have this line. All right. That will go on forever. Both directions, and I can put it. Oops, it's purple. All right. And it's going to go on like that. Now, so from here, we're going to try to figure out what is the equation of that line. So I have y equals m x minus our x value of a point that we've chosen. Well, I chose A. You could use B, but I chose A. We're going to take our x coordinates. This is our x sub 1. We're going to plug that in there. So we have -3. So x minus, this is transformation. We're going to have x plus 3. And we're going to have plus 2. All right. So that is, we use our point. And now what we need to do is find our slope. And if you're wondering where the y2 or y1 came from, that's what we got right there. All right, now let's find our slope. Our slope is a ratio. It's a ratio of the change in y over the change in x. So what we're going to do is we can do this many different ways. You could take your 2 points and actually write it out. Oops, that should be a 1 there. Sorry. All right. Or we can do a math equation. So if you go over here, you can actually find this rise over run by creating a right triangle, because that's where the ratio is. So we're going to rise, because that's our change in y's. That's why you always hear rise over run. All right. Rise. So we can go, it's going from 1, 2, 3, 4. So it's going up 4, it appears. And then we are running. All right, we are running. So we're going up 4, and we're running from here to there. So we're going to left 1, 2, 2. And actually, this slope is going down. This is a negative slope. I'm going to put negative 2 here. Well, depending on how you look at it. So I'm starting here. Running up, running to the left. So that's why it's negative. All right, if you went down here, it'd be going negative 4 over the right 2. So it'd be negative 4 over 2, which either case, we find our slope is equal to negative 2. Now, this is a pretty elementary problem. It's not too hard, all right? But hopefully don't find it too hard. But from here, we can take our slope then, plug in our equation, and so now what we have is y equals negative 2, all right, times, now how does it transform? Well, normally, we would have negative 2x, but since it's been shifted over to the left 3 units, because we went over here, negative 3 units, and we went up 2, so we did a transformation here. And so we have x plus 3 plus 2, and that's our equation of our line, our point and our slope. Now, how would you find slope-intercept form? Well, slope-intercept form takes it, and a lot of students get hung up on this because they're like, I don't know my y-intercept, I don't know my y-intercept. Well, slope-intercept form is actually just a function form of the function in terms of y. So essentially, all you have to do, I'm going to change a different color here, make it green. We're all going to do is we're just going to simplify this expression. So we're going to distribute the negative 2 through. So you have negative 2x. We have minus 6. That's what we have. We have plus 2. That can be simplified to negative 2x minus 4 equals y. And that's our slope-intercept form. Our slope-intercept form, we can see that our slope is negative 2 because the negative, or this number next to the x, this is what our slope is. The other number is a constant, all right? It's a constant. So what is this number over here? Well, in slope-intercept form, this is what's known as the y-intercept. The y-intercept, okay? What is the y-intercept? Well, the y-intercept is where the equation line intersects the y-axis. So essentially, when you see a point, the y-intercept actually is a point. It's a point of, well, you have 0 because if it intercepts the y-intercept, x is 0. And in this case, negative 4 is going to be your y-intercept. And you can take that out by plugging 0 in for x, which is 0. Y equals negative 4, and there you go. So down here, if I wanted to extend out this graph, this would go down through here. And so we have a nice equation or a line that looks like this. It's beautiful and goes on forever in every direction. We could also write this in general form if we wanted to. It's pretty easy. General form, one of the keys is we need to make this into a all right, implicit equation. So if we were to write this as an implicit equation, we need to have x and y on the same side. And our coefficient x has to be positive. So what we would have is 2x. I'm going to add 2x to the other side. We have plus y equals negative 4. Sometimes we don't like to have the negative there, so you subtract it through, or you can leave it like negative 4, but that is what's known as general form. This is an implicit form. You can simplify it any which way you want. It's good, bad, ugly, but for the most part, I always work with point slope form, all right, and then I can reduce it to slope-intercept form. 2 different great ways, all right, find the equation of a line. But the key thing is, what do you need to find the equation of a line? You need to find the slope of the line and you need, the slope of the line and a point on the line. That's it. Well, let's try a little more. All right, find the equation of a line given these coordinates. So A and B. All right, so we have A. Graph this real quick. Probably already know this. So if we go over here, 1 and 1. All right, 1, 1, here's A. We have 2, 1, 2, 1. Here's B. Connect the dots. Right here. All right, well, now if you're advanced, you probably already noticed that this line looks parallel. Parallel means there's no change, all right, from the horizontal axis or the x-axis. This is known as the x-axis, it's the y-axis. We're doing this. Now, there is no slope here because it's a horizontal line. Well, how do we know it's a horizontal, or how do we know there's no slope? Well, let's figure it out. We'll actually do the math here. All right, you can see that this rise is 0. Rise or run. All right, rise is 0 and runs basically everywhere, but if you say it just runs 1. All right, because these are the same numbers. How can you figure this out? Well, y2 minus y1 over x2 minus x1. Let's just write this out. We'll use this as x2. So, and y2, why not? So 1 minus 1 is in these two. All right, so it's my y2, my y1. You can define these any way you want. All right, x2 then, this has to be next to x1, so that'd be 2. Minus this has to be x1 because it has to be with the other one. How do you figure this out? Honestly, this was the hardest thing when I first was doing math. Which one's x1? Which one's y1? It doesn't matter. All right, just pick one. All right, and go with it. So right here, if this is x1, this has to be x2. So we have 0 over 1. And there you have it. Our slope is 0. Okay, well, let's put that into our point slope form. Well, y equals, we have a 0 slope. We have x minus our point. Let's pick this one because it's 1, 1. It's pretty easy. 1 minus 1. And we're going to add our y, which is 1. All right? Well, that's our equation. Well, we normally wouldn't leave like that, so what we have is y equals 1. That's actually our slope-intercept form. And that is our equation. Y equals 1. And this is what's known as a horizontal line. A horizontal line has a slope of 0. So all horizontal lines have a slope of 0. All right, well, what did we learn today? Well, we learned that how to identify horizontal lines. They have a slope of 0. But more importantly, how do you find the equation of a line? You need a slope and you need a point of that line. It works every single time. And once you use that point slope form, you can go through and simplify it to any form you want. But point slope form is the key because it's important to know that you need a point and a slope to find the equation of a line. I hope this helps you out on doing lines and how to find their equations. And hopefully you can understand the difference between all these different equations like that. All right, so good luck and God bless in the rest of your homework.